Second part of the talk about Ohm and Kirchhoff's laws. This time having a look at a few examples and the concept of ground. We'll start with a few examples. We've seen this example already, and about the only thing I want to add to it is the fact that this resistor is 1K, 1 kilo ohm, or 1000 ohms. And that is the ratio of the voltage across the resistor, 3, to the current through the resistor, 3 milliamps. The resistance, according to Ohm's law, remembering that Ohm's law is, is delta V 12 equals I 12 times R. I don't usually write the 12s, they're just to remind me what the voltage difference is across and which direction the current is. V1 minus V2 equals I12R, where I is the current from node 1 to node 2. So in the case of this circuit here, we've got 3 volts at the top of the resistor. We have a 1K resistor, and we have ground, this point here, or 0 volts, at the bottom of the resistor. So if this is node 1 and this is node 2, then V1 is 3, V2 is 0, I12 is the current flowing through the resistor, which we can see is 3 milliamps, and that's the current flowing from 1 to 2, and R is the value of the resistor. So R is 3 divided by 3 milli, which is 1000, which we usually write as 1K. And it is a 1K resistor, that's fine. What if the voltage was negative? Maybe, say, minus 3 volts. First thing you notice is that the current is now flowing in the other direction. It's flowing up through the resistor, where it used to flow down through the resistor. And that's because current always flows through a resistor from the higher voltage to the lower voltage. And now the lower voltage is minus 3 at the top, and the higher voltage is at the bottom, it's 0. We can apply the same formula, exactly the same argument. This time, V1 is minus 3. V2 is still 0. I12 times R. The R is 1K. That would imply that the current from 1 to 2 is minus 3 divided by 1000, which we write as minus 3 milliamps. That is perhaps initially slightly confusing, but very important to get your head round because it happens a lot. A current of minus 3 milliamps flowing from node 1 to node 2, i.e. that would be down the resistor in this direction, is the same thing as a current of 3 milliamps flowing up through the resistor from the bottom to the top. A negative current is just a positive current flowing in the other direction. The ammeter, you'll see, is measuring minus 3 milliamps. And that's because ammeters always measure the current flowing into the red terminal and out of the black terminal. This ammeter is measuring minus 3 milliamps flowing this way, from left to right. Minus 3 milliamps flowing in that direction is the same thing as 3 milliamps flowing in that direction. And in fact, if we took this ammeter and turned it around and wired it back up again, it would now be reading plus 3 milliamps, because it's now reading the current in this direction, from right to left, the direction the current is actually flowing in. Okay, Other thing I wanted to mention in this little chat is this concept of ground. That symbol there means ground. It's 0 volts. Since Ohm's law is entirely concerned with the difference between the voltages at any 2 points in a circuit, you are often free to just assign the voltage at 1 point in your circuit as being 0, and then measure all of the other voltages in the circuit relevant to that point in relation to that 0. They can be above that fixed point or below that fixed point, positive or negative voltages. And for something like a battery-powered circuit, it's arbitrary which point you take as your ground. There is a related concept of mains earth. Now, mains earth literally is the potential of the earth. You take a big metal spike, you drive it into the ground, you attach a cable to it, that you take as your 0. You can think of that technique in terms of the hydraulic analogy a bit like the ocean. You're putting a small amount of water into the ocean or taking a small amount of water out of the ocean, the level of the ocean isn't going to change. You could think of it perhaps like the pressure of air in the atmosphere. If air leaks out of a balloon, or you pump air into a balloon, the pressure inside that balloon changes, but the pressure of the air outside the balloon isn't going to change significantly, effectively constant. And we often take that as being our 0 voltage reference. We draw it like this. I could draw it like this and actually show that it was, oops, come on down, thank you, was a 0 volt point. The two mean pretty much exactly the same thing. It's just convention that it's drawn like this with 3 horizontal lines. It means 0 volts. And every point in the circuit which is connected to that node is effectively connected together. I could draw the circuit equally well like this. Just get another one of them, put it down there. That is exactly the same circuit. These 2 points are connected together. They're both connected to ground. Right. I think that's all I wanted to say this time. Next time, we'll move on and have a look at the first of Kirchhoff's laws.